Hey, thanks DPDK and community for selecting our presentation, which is a small talk on a eBPF props in DPDK. Today I'm accompanied with Shiva. He's my colleague, and we have been working and helping clients, users, and even people from Stack Overflow and GitHub and all with regard to DPDK solutions, applications, and even performance tuning and all. So, since the talk is on eBPF, a small primer. Number one, we have seen, or most of us has heard about kernel eBPF and all. We know that it was initially started for the TCP dump with BPF and all. Later it got into packet filtering, SKB filtering, traffic classification, and all those things. There is also an interesting project which is known as XTB project, which makes use of eBPF to filter forward, drop, and do some action matches and LPM matches and all just before the packet enters into the network space, thus achieving something very similar to a line rate of a hardware NIC. Now, the topic what we are talking about is making use of DPDK eBPF. To give a small history about it, it got added from 1811 onwards, and obviously it works in user space of DPDK. If we look at the test PMD example, this is implemented in the callback handlers of RX and TX callback handlers and all. Today, as I recollect, it works on x86 and ARM platform. The just-in-time activity works it. But please do not, unlike the kernel eBPF, it does not have access to the BPF map, hash maps, array per CPU, LPMs, and even socket maps, what is available in the kernel. So the DPDK eBPF is purely based on user space. So with that primer, let me just give you the agenda, what we are trying to cover. What is our problem statement? Why we think it is relevant for a dynamic user probing with eBPF? How one can make use of eBPF to debug and monitor dynamically. And last but not the least, a couple of screenshots of the sample application that we have built and what the future could be. Over to you, Shiva. I think Shiva has some difficulty, so I'll just continue ahead with it. Okay, the current layout that we see with respect to that application is a sample representation of a telco or an enterprise customer, which makes use of DPDK as a packet processing pipeline and all. So there are multiple stages where packet comes in, events are created, it fans out, it fans in, and packets are processed. So there are numerous places where problems could arise. So we categorize customers saying stage 1, stage 2, stage 3. For stage 1 customers, a couple of years back, we added a small troubleshoot guide as a how-to guide, identifying some of the core problems, what to do, where to check, how to do, and all. That is what we shared and all. That was helping out customers and all. Once they got comfortable with it, as you can see in slide 6, what ended up is that customer came back and told, hey, we don't want to put all the debugs at every place. We want to have selective debugs highlighted. And those are the green color boxes that we say. Certain pipelines, certain stages, we have some selective debugs that is going on. With this, what we ended up doing is, for a particular customer, we had to create a macro as a hash define, and if a problem occurred, to debug it, we had to go and rebuild the complete entire application. We had to redeploy it, we had to get the statistics, we had to correlate and cross relate things, identify what is the problem. If not enough data is collected, we have to reiterate it. So the turnaround time which is required for building the entire app, getting it deployed, getting the statistics back, and doing things was not good. We wanted to find a way to reduce this. That is where we came up with a couple of solutions, which we are already shared in our last DPDK summits and even shared in our GitHub too. That is, for example, the binary that gets deployed onto a field node, whether it is running on a bare metal or Docker or even a VM, might be running on an environment which might not support remote GDB for security reason. It might have its debug simples and other things stripped out. So end of the day, any crash, a segmentation fault, and all what we see from the customers is not with clarity. We don't have any clarity at all. This prompted us to explore the use of libunwind to be added to the customer application and add a dependency of libunwind and get the stack register dump and all. So one such scenario, we found segmentation fault occurring for a very good non-problematic packet. Now with this tool, we were able to identify the flow table pointer that we had was corrupted. Now we started scratching our head trying to figure out from who corrupted that pointer table, which was not, which was like one set. It was not supposed to be modified, but someone in the middle of it had modified it. So we created yet another tool called as memzone monitor, which is a standalone secondary process which keeps track for your selected tables and selected entries. As soon as you see a change in the given set of values or given one value, it triggers a core dump, or it triggers a sig call which invokes the lib unwind GDB and collect the traces. With that, we were able to figure out, hey, there is an exception path packet, and at a given line rate and at a given combination, when this exception packet came with more than 3 segments, there was some pointer mismatch and improper handling, which led to the pointer corruption and all, which thereby caused for future table lookups and flow cache lookups to go invalid. So with memzone monitor, now we realize that there is a problem and we were able to detect it. Similarly, there was a ask, hey, DPDK RT malloc, zmalloc, calloc and all, even though it takes the name as an argument, it does not keep track of the growth of things. So we ended up writing a small secondary application with FB array, which and added that custom overrider, which allowed us to track and showcase for this namespace under RT malloc, hey, this much is used right now. Realloc is invoked for the same pointer, so it increase or decrease in size and all. So what we are trying to say, for stage 2 customer, where they get to see complicated problems and all, a timely fashion at specific points were not available, which forced us to create such tools and all. But really, does this solve the problem for us? No, we were yet bombarded with multiple requests. Hey, you suggested this particular model, this particular event dave. You suggested I can pin this particular hash values to these worker cores, and for cache locality, do this, do that, and all. Still, I don't get the performance when some specific scenario is hitting and other things is working. When I do a worker core reduction, and then when I go for a worker core expansion for more number of workloads and all, it is not working. There is an inconsistency in how the traffic forms and all. So all these were our still more problems came to us. So you moved a customer from getting started with DPDK from stage 1, you moved to stage 2, where they are better equipped for building and all. For those people, when the problems comes, to identify and locate it was not easy. Now we have stage 3 type of customers, where they are acquainted with the libraries, binaries and all those things, but still there is less visibility in what is happening inside. So this, when we collected all the different requests like what we see in slide 9, we came to understand that, hey, the debug requirements keeps on changing dynamically. The problem faced by customer 1 today is not the problem not faced by them day after tomorrow. It keeps on changing. The time that is taken to debug and identify the things and put it, that is building, reiterating, getting telemetry statistics, comparing, rebuilding it and deploying it, it is too much of time, and it is very cumbersome, because you are dependent upon the cross build environment, you are dependent upon the third party dependency, and you are dependent upon the final application. Not 99% of the customer never shares their application code, which makes it very difficult even to suggest even the hash if devs that we have seen earlier too. So we needed something that is architectural independent. It has very less dependency on which DPDK version we use, and with a laptop I should be able to create that bytecode which can be loaded or executed at any point of time. This led us to find out what would be an ideal probe in slide 10, wherein which we discuss and we agreed on an ideal probe when compared to DPDK procinfo, pdump, or even with LTTNG logging, should be completely independent of your tool chain. You should be able to create that bytecode, and it should be architectural independent. It should have zero or minimal dependency on DPDK. It should have zero or minimal dependency on user library. Similarly, if you want to invoke DPDK functions, or if you want to invoke third-party libraries, you should have a extend pointer access to it and all. So these were some of the collective understanding which made us to go and replace that hash ifs, what we showcase in the green trace points, with our BPF byte independent code there. So why do we need it? We need it for dynamic debug. Let's say, hey, I have a worker from which gets traffic from the event day, which is spread to 8 workers. In this, I want to see which worker is getting which type of flow, or what is the hash value, what is the first 3 bits of the flow ID to pinpoint and tell, hey, these set of flow IDs are coming to worker 1, these set of flows are coming to worker 2. Then thereby calculate and identify which is the mostly used worker and all. So it is so we can use this eBPF for those kind of small logic and all. It does not depend upon the tool chain and other things. If you're writing it completely independent of third-party library and DPDK, then the predefined trace points is still there. That is the if condition checks. We are not changing much of it. So you need not recompile the entire library. You need not have remote GDP dependencies. Even if the binaries are stripped, you're not depending upon the binary to do it. Similarly, the green color eBPF binaries that we load, if you are making use of DPDK, you can call the lookup ACL or even the counter. You can access the memzone counter or the RT-malloc counters and all. So here is a small comparison slide 12 where we are stating, hey, the left hand side is calling, it can call hex dump and RT packet dump if you know what type of packet it is. And the right hand side shows a eBPF code which is completely independent of any DPDK libraries and all, and can be totally independent. Both these cases we can, if you want to generate it as a standalone library, this is a clang command that you have to use. If you're going to make use of the RT libraries, the includes, and even the function call, we have to just pass these parameters with the right library, and you get on the right hand side byte independent code. This byte independent code can be then executed in any point of your application, and you can get your desired result. Now, just to give a glimpse, what we did is we took DPDK example like event day. We looked at the various workers that we have. Let's say I had 8 workers or 16 workers. We inserted this trace part into the area where before we do the enqueue, we collect what you can go and execute the eBPF code. After before you do DQ from the port, after you do the enqueue or just before you do the enqueue, you can call yet another trace. Like that, for 8 workers, we created 2 trace points each, and we loaded up some of the trace point to see what it can behave. So just to give a glimpse, like I said, we use the event day pipeline example. We allowed around 25 gig of traffic to be passed into it. The bridge driver, based on the RSS value, distributed it as the flow ID to 8 of the workers. And if the 8 probes, the 8 if condition checks, okay, where none of them are loading any eBPF, the degradation in the throughput that we get to see is 0.5% less. If 2 of the traces are activated, where we just check, hey, is the event day flow ID greater than 10? Is the event day flow ID is modulo of 10? Something like that. What we get to see is a 1% degradation in total throughput and all. We went a little bit further. We added the same 2 trace points to do that pointer check for the event day flow ID. Along with that, we activated one more trace, wherein which we did a simple lookup. That lookup table was populated by a service core telling which worker on an average per second how many DQs and NQs it is doing, and thereby getting a rough estimate. So in the third probe, we did that lookup and try to match whether this flow ID is part of that particular worker or not. Like that, we did a lookup. In that case, we saw a overall degradation of 3.8. So to summarize it, what we ended up seeing is certain worker, based on the traffic type, based on the time at which it was running and all, You have DQ that is happening frequently and NQ that is happening frequently. But certain time intervals where there were less amount of traffic, or when the traffic got changed, or when the burstiness went away, we get to see that most of the underlying time period, it was blank and simple. So this led us to proclaim that, hey, there are certain events at which you can redirect. Instead of having 8 worker, you can cut down and dynamically change the port assignment, which allowed you to redirect it to 4 worker instead of 8. So dynamically allowing us to increase and decrease the number of worker getting utilized for it. So this is what the experimentation led us to do. Just checking on time. I believe we have 3-4 minutes more. So what we are doing today with eBPF. 8 months back, we came across an interesting problem. We had the binary created by, or the application created by the customer in bare metal with a specific vendor nick and all. Now he wanted to use the same binary in his Docker or VM, but the interface that was exposed to it was a Vert.io. That particular programmable or smart nick, or that foundational nick what we had, whatever metadata it was populating and adding into the private metadata, now that handler was not there. So what we ended up is, we gave this option of eBPF to be loaded, so that he does not need to change the code by adding a new RX callback. He just wanted to insert the eBPF, which does that minimalistic check for his desired application. For example, in our case, it was a GTPU tunnel ID, and then get the packet through. The second scenario where we found this to be very useful is, now suppose we have a scenario wherein which we get packets, and this we have the ring distributor library in DPDK, which spreads based on the static RSS. And like I mentioned earlier, since we can invoke the RTE lookup and RTE exact match calls from DPDK using eBPF, now instead of just statically dividing the RSS or the hash values among the worker, you can at least check the worker load and fall back to an alternative worker and all. So these kind of things we were able to do. Last but not the least, we also found eBPF especially useful in our upcoming talk, wherein which we worked on the Qt to parse, drop, or forward packets to the right ring buffer too. Thus, eBPF in the user space in DPDK achieves 3 major goals for us without having the end user toolchain, or without having the cross environment. We can create a byte independent code which is not only useful for dynamic debugging and all. You can create it from a laptop and you can give the binary to the vendor, or the vendor can you can give the code, vendor can create that binary and add these trace point. Also, we are finding it useful in these kind of scenarios where it augments the features when you move from bare metal to Docker or even VM. Now, earlier we mentioned about the malloc monitor, memzone, and no GDB and all. These are some of the GitHub links where you can make use of it. So thank you for hearing me out. What I would like to do now is I would like to look up in the chat if there is any questions and all, and get it answered up. Okay, so we have one question. How does from Thomas? How does BPF hook perf compares to the RT trace perf when not activated? Good question. Only problem is that I have not tried it out because this talk was actually built up and planned for the earlier summit. Right now, it did not. We just got an opportunity today, so I would like to do that in the future, Thomas. I'll try to get that and reach out to you. Can you stop sharing screen? Yes, definitely, David. Thank you. I stopped sharing. Okay. So any more questions? Anything? I think no. Unfortunately, my friend Shiva had a connectivity issue. Sorry for that. And thank you. Have a good day. God bless. Stay safe.